You've probably noticed that AI coding tools like Codex and Claude are just everywhere now. But they're not just simple tools anymore, right? They're evolving into these autonomous teammates that can plan and execute complex coding tasks right alongside us. They can write brand new features, they can fix bugs, but what happens when we ask them to clean up our existing code? And that, right there, is the big question we're digging into today. We know these AI agents can churn out code, but when they try to improve what's already there through a process called refactoring, are they actually helping or are they just shuffling deck chairs on the Titanic? Well, to find out, we're diving deep into a massive new study that finally gives us some real data-backed answers. Okay, so before we get into the weeds, let's make sure we're all on the same page with this word, refactoring. This isn't about adding cool new buttons or fixing a crash. It's all about restructuring the inside of the code. The goal is to make it cleaner, more efficient, and way easier to work with down the road, all without changing a single thing the user actually sees on the outside. It's absolutely crucial for keeping software healthy in the long run. So, to get to the bottom of this mystery, researchers went big. They conducted this huge study looking at AI-generated refactorings to see how these new teammates are actually behaving out in the real world in actual open-source projects. Okay, check this out. This slide is a perfect example of what we're talking about. On the left, you've got this block of code that's all crammed into one single main method. Kind of clunky, right? Well, the AI agent looked at that and decided, nope, we can do better. And on the right, you see the result. It's intelligently pulled that logic out into two clean, separate helper methods. The code is instantly more readable. It almost tells a story. That is agentic refactoring in action. So how on earth did the researchers figure all this out? To really trust the results, you have to understand the method. And they followed this super systematic process to sift through an absolute mountain of data to find the proof they needed. Their starting point was something called the AI Dev dataset. And you guys, this thing is enormous. It's a massive collection of code contributions made by AI agents on GitHub. We're talking more than 1.3 million commits. So this isn't some tiny little lab experiment. This is a full-blown analysis of AI behavior out in the wild. They used a really rigorous 4-step process, which you can see right here. First up, data mining, where they grabbed all those 1.3 million commits. Next, data filtering. They had to cut through the noise, so they narrowed it down to just over 1,600 Java projects. Then the cool part. They used a special tool called Refactoring Miner to automatically scan the code and find refactorings. And finally, to make sure they were only looking at the right stuff, they analyzed the commit messages to identify agent activity, zeroing in on commits where the AI's stated goal was to refactor or clean up the code. And after all that digging and filtering, this is what they were left with. A super high-quality dataset of 15,451 distinct refactoring operations, all performed by AI agents. This number is so important because it gives their findings some serious weight. We're talking about a huge sample size here. All right, so they've got their data, the stage is set. What did they actually find? What secrets did all that code reveal about our new AI teammates? Well, the first big clue is all about how often this happens. And it turns out refactoring is a really common and, more importantly, intentional activity for these AIs. A little over a quarter of the time, 26.1% to be exact, the AI's stated purpose was to refactor the code. So this isn't just happening by accident. We are actively telling our AIs to go in and clean house. But here's where it gets really fascinating. What kind of refactoring are they doing? The study found this major difference between AIs and humans. Agents are doing way more low-level changes, small, focused edits inside a single file. Humans, on the other hand, tend to tackle more high-level, architectural stuff that impacts the whole system. You could almost say that right now, agents are acting more like code janitors than software architects. And if you're wondering what that low-level work actually looks like, here you go. The top 3 refactoring types for AIs are all about consistency and just general tidiness. Changing variable types, renaming parameters, renaming variables. Get this, these 3 simple tasks alone make up over 30% of everything the agents are doing. It's valuable work for sure, but it's very much about polishing the little details. So why are we asking the AIs to do this? Well, the motivation is overwhelmingly about improving long-term maintainability. Over half of all agent refactoring commits were aimed at making the code easier to deal with in the future. And that's a huge contrast with humans, who tend to refactor more for immediate readability. It seems like we're using AI to do the important but kind of tedious chores that keep our codebase healthy over the long haul. Okay, the investigation is done, all the evidence is in. Let's take a step back and look at the big picture. What's the final verdict on our AI coding partners? Verdict part 1 is pretty clear. AI agents are fantastic cleanup partners. They are absolutely brilliant at the routine, localized, consistency-focused tasks that keep a codebase from getting messy. They're reliable for handling all the small stuff that really adds up over time. But, and this is a really big but, they are not yet software architects. They just don't have that deep contextual understanding you need to make complex, high-level design changes. Think of it this way. They can clean a room perfectly, but they can't redesign the house. Not yet anyway. And this quote from the paper just hits the nail on the head. So here's the bottom line. While the changes agents make are statistically good, the improvements themselves are small. They make the code a little tidier, sure, but they don't consistently fix the deeper design flaws, what developers call code smells. Those are the things that hint at a much bigger problem. So the agents are cleaning the surface, but they're not tackling the root causes of our technical. So with that verdict in mind, what are the practical takeaways? Let's break down what all these findings mean for the different people building software today. For all you developers out there, the message is pretty clear. Use these agents strategically. Delegate the cleanup work. Let your AI partner handle all that tedious renaming and busy work. That frees you up to focus on the big picture design where your human brain is most valuable. But, and this is important, review their work carefully. The study found that agents often create what are called tangled commits, where they mix cleanup with new features, and that can make code reviews a real headache. And for the researchers, this study isn't an ending, it's a huge beginning. It opens up so many new questions, like what's the real productivity cost of those tangled commits? We also desperately need better benchmarks to actually train and test AIs on those tough, high-level refactoring tasks. And we need to study the long-term effects. Does all this AI cleanup actually lead to fewer bugs down the line? We just don't know yet. Finally, for the brilliant folks who are actually building these AI tools, there's a pretty clear roadmap for what's next. The next big challenge is training agents to graduate from being cleanup partners to being actual architectural planners. They need to learn good commit hygiene, separating their refactoring from other work, and most importantly, they need to be armed with tools that can find and fix those deeper code smells, so they can stop just tidying the surface and start reinforcing the foundation. Hey, if you enjoy this deep dive that breaks down a complex topic without making your brain feel like it's about to throw a null pointer exception, do us a massive favor and smash that subscribe button for VibeDoc. Seriously, it's the best way to tell the algorithm that we're doing something right over here. And we'll leave you with this final thought to chew on. Right now, AIs are our tireless cleanup crew, but they're learning incredibly fast. So the question isn't really if they'll become software architects, it's when. And when that day finally comes, the even bigger question will be, should we let them take the lead? Thanks for joining us.